Welcome to third person camera control. This is going to get fun. So by the end of the video we will have a rudimentary but error-prone camera rotation system. We'll be able to move around the tank. We'll have some glitches. We'll have a common problem with the camera ending up rotating like this, the horizon ending up not horizontal, but this is good. This is a step towards the camera control we want. And because of the flexibility of Blueprint, we are going to be able to fix the hierarchy, fix what we need, and swap a couple of elements out really quickly after the video. But for now, I want you to get this initial thing set up, a very simple system, and we will have camera control. So let's go and see how it works. So let's take a look at what's happening with the camera. I'm going to get the world outliner up, play the game, and see what's happening. If we depossess, where's our camera? Well, it's right at the origin of the tank, right underneath it. Where is it in the world here? Do we have a camera in the world? We have a player camera manager, and you can see that's where it is there. And it's a thing of type player camera manager. Okay, so what we want to do is we want to attach a camera to the blueprint, the tank blueprint. So let's go ahead and do that together now. Open up your tank blueprint. And the naive way to do this, and we'll start by doing this, is just to go and add a component, add a camera, then we move the camera and position it up and behind the tank. Now this is basically fine. But there are some issues with it, which we'll see in a moment, because it's going to be hard to rotate the camera, and also the camera is not going to particularly nicely follow the tank with a kind of springy feel to it. But let's just see what this is like. If there is a camera attached to the tank and then we play, you see what's happening? Now it's found a camera, so so there we go. We're where we want to be, up and behind the tank. But we want some way of moving the camera around. So how are we going to do that? Well, we can't just rotate the camera, right? Because that would do something really strange if you think about it. If we had some controls that just rotate the camera, we'd just be looking away from the tank. We can indeed just move the tank, but we don't want to rotate the tank randomly because the tank rotation should be based on its movement, right? So we're going to have to put the camera on an arm, and that's something called a spring arm, and then rotate that spring arm. So that's what we're going to be doing here. So let's start by adding a spring arm. Camera spring arm. It's designed for cameras. I can just call it a spring arm, that's fine, but we want to child the camera to it. So now what's happening is you've got this virtual spring arm in the world, and if you rotate that, you see how the camera goes with it? Okay, so let's just play the game and see what's happening with it on the spring arm. It'll be very similar. Okay, that's fine. It's pointing a little bit at the ground, so maybe come back a click. Great, okay, still not quite pointing in the right place. So there's two angles, of course, here. You've got how kind of high the camera is based on the rotation of the spring arm. Imagine a line going from the center of the tank out to the camera, but also, of course, you're still free to rotate the camera itself. So just fiddle around with it until you get a reasonable view. Something like that isn't far off. Okay, we can tweak that later. But importantly now, what we want to be able to do is we want to be able to rotate and move this spring arm. So when we look around, we want the camera to orbit around the tank like that. So we're going to set up this input binding now. We're going to do it in Blueprint. Don't worry, this section has over 500 lines of juicy C++ code to get into, but this is very simple. We're just going to take an input axis and do a very simple manipulation of it, and we're going to be referencing this spring arm, or perhaps a spring arm container, we'll see in a moment. So because we're referencing input and we're referencing an actual asset in the game, they're both candidates for using Blueprint. There's no point in going from Blueprint to C++ back out to Blueprint. Let's just keep it all in Blueprint in this case. So let's take ourselves to the event graph of the tank blueprint. By the way, the event graph is just one of potentially many event graphs. So here we have My Blueprint tab. If you can find the My Blueprint tab, if you can't, then you can have a look on the window menu and you'll find My Blueprint there. And this My Blueprint tab will show you all sorts of things which you'll come to discover in this section. But one of them is that the event graph is not the only place that we can add Blueprint code, actual execution flow code, to our tank. We could add another graph. So let's do that. Let's add another graph called input setup. And that will work exactly like the event graph. In fact, it is an event graph. It's just that you can't rename event graph. There has to be one thing called event graph, and you can have as many other event graphs as you like, or graphs as you like. The only thing is that you can't have a begin play on both, otherwise it wouldn't know where to start. But we're not dealing with begin play, so let's put all our input into a separate graph from the word go, just to organize them basically, just as an organizational tool. Cool, so I'm going to go ahead and do a tiny bit of input binding now. So we go to our project settings, however you want to get to it. One way is the toolbar, project settings. Just hide that tab, give myself some more room. Let's start setting up some input. What have we already got input-wise? Nothing. We've got no action, no axes. So your first question is this an action or an axis if we're going to move the camera? Well, it's an axis, isn't it? We're going to use, say, the right stick on a gamepad or the mouse or something like that. So let's start off just with the mouse. Now, what are we going to call these axes? Well, I'm going to call it aim azimuth. Now, what is aim azimuth? Well, if you pop over to Wikipedia and look for horizontal coordinate system, there is a link in your notes. Then we have azimuth and altitude, or in the case of the tank, I'd prefer it to call it azimuth and elevation. That is what we are moving the camera in. Azimuth means moving it around horizontally, looking at a different part of the sky horizontally, and elevation or altitude means looking up and down. So we're going to use an azimuth and elevation model. Okay, so we have aim azimuth. Now, I'm not going to add the other one. This is going to be part of your challenge, but I am going to start binding it to a couple of different things, I think. We're going to have the mouse x-axis, and we're also going to have the, no, that's it, actually. Actually, I'm going to use the gamepad right thumbstick x-axis. Going to give myself two options from the WordCo. Now, the scaling, this is something that the user may use to control the sensitivity of their controls. We don't generally want to change that. We want to set it at a sensible value, but we don't tweak it here. This is really for a user to tweak later. All right, so we have two things that are leading to aim azimuth. Okay, great. Now, let's go to the tank blueprint and let's go find azimuth. There you go, aim azimuth, it's an event. So when that aim azimuth input is triggered, what are we going to do? Well, we're going to add a local rotation. So come off the execution pin and look for local rotation. Add actor local rotation, or just add local rotation to the spring arm. Here you go. So we're going to add local rotation to a component, not the actor itself, because that's the tank. Remember, we're on the tank blueprint. So out of all of these options, it's not the actor because it's not the tank, it is the spring arm. We're going to add a local rotation to the spring arm. You see it's found the reference to the spring arm, which is quite helpful for us. Okay, and then we need to decide, well, how much rotation do we give to the spring arm? Well, it's pretty much just this axis value. The only problem with just piping this axis value in is that it would then depend on the frame rate, right? Because in a particular frame, we would rotate a different amount depending on how long the frame is. So what we're going to do is we're going to get the world delta seconds, That's going to output how long the last frame was. We're going to multiply, so there's a float times float multiplication there. The axis value, well, now I don't want to cross the nodes, it just looks ugly, so let's just mess around with that. We're going to multiply the axis value that's coming out between 0 and 1 with how long the previous frame was and use that for our rotation. But we need to split this struct. So if you just right-click on delta rotation, you can split struct pin. And that allows us to pipe this into the yaw, right? Azimuth is yaw in aeroplane terms. So just stop all the crossing of the nodes. Doesn't matter functionally, of course, these nodes crossing. It just matters aesthetically. And that's it. That is how we would set up the input control for the axis. Let's try it. Let's compile a blueprint, come into the game, and try just moving our mouse. Now, it is working. It's just working very slowly, all right? So how do we sort that out? Well, that multiply pin here has the ability to add another pin. We do that, and we put a fixed 100 in here, for example. So we got the axis value times how long the frame was times 100. Let's try that. We're just increasing the speed. Now the mouse x-axis does exactly what we want. A little bit glitchy, but we'll worry about this later. Okay, and then the right axis of my gamepad also does the same thing. That's cool. So I wonder why that's snapping like that. We're getting a sudden snapping of our camera position. Well, we'll take a look at that in the next video, but what I want you to do now is a challenge. I want you to set up the aim elevation for me. So I want you to bind the aim elevation in Blueprint for me. Use the aim azimuth as a template, set up the corresponding binding for the elevation, and just test that it all works. Make sure you really understood what I just told you. So go ahead, pause the video, and work the same magic for the elevation right now. Welcome back. Let's take a look at how to make this work. So of course, the first thing that we need to do is go into our project settings, into input, and then we need to come down to the axis mappings and give ourselves a similar one, aim elevation. Oops, with a few extra letters there. It almost looks Scandinavian in its spelling just then. So mouse Y is one of our options, and gamepad right thumbstick Y axis is what we want. There you go. So now we have an aim elevation. Remember, copy and paste is the safest way of using this, although we don't need to in the case of Blueprint because we're going to reference it directly like this. Well, still paste, aim elevation, make sure I'm getting the right thing. It's the event we want, not a function. And then we are simply going to do exactly the same thing. So basically, because we're doing exactly the same thing, we can come off the elevation node, we can look for local rotation, add local rotation to the spring arm, add local rotation to the spring arm. That gives us most of what we wanted. These nodes we can just copy and paste, wire things up. Now we need to split the struct here. Now, which one did you opt to put it into? If we're doing elevation, what are you doing? Are you pitching, yawing, or rolling the camera? I think we're pitching the camera. We've still got that 100 multiplier, which should be appropriate. It should give us a similar effect. Collapse that node down a little bit, and I'll tidy this blueprint up at the end. Let's make sure it works before we tidy it up, so I'll stop tidying it. I'm obsessively tidying it. Come to the battleground, play the game, and then look, the camera is moving around, but it's doing something really strange, okay? And the reason for that is because we need yet another level of indirection here. We need to not just be rotating the spring arm, because the rotations are compounding. If we pan the spring arm or move the spring arm in azimuth and then elevate it and then move it in azimuth again, then what we're ending up with is we're ending up with the wrong end result. So let me show you that in action. Here's the spring arm, for instance. If I take the spring arm up like that and then round and then down, it's going to start twisting. So let's see how this looks. You see how it's twisted? The horizon is no longer steady. And that's just because of the way these rotations are adding together. They don't add together in a way that is independent of the order you've done them in with rotations, of course. So what we want to do then is we want to have another object, and we'll put another object, a spring arm container, in between in the next video. So I'm just going to try and return my camera to where it was, which I think was there. Let's try that. And make sure that we start in a sensible position. Yeah, and I'm going to accept that a combination of movements is going to end up with us in a really strange position. So we'll see how to sort that out next, but at least we have the bindings that we need. I'm going to just go to the Input Setup tab again, tidy up my blueprint. I think that's a good habit once you know that it works. Don't waste your time beforehand if you can possibly help it. I know if you're tidy-minded like me, you won't be able to help it, and if you're not tidy-minded, then you wonder what I'm spending all the time on. And what I'm going to do here is I'm going to highlight all the nodes and push the C key, C for comment on the keyboard. And I'm just going to say exactly what this is. This is camera input binding. And then that's it. We are done. Let's save everything. Remember to be using source control. I haven't showed you any commits going on recently, but I am, once I've saved everything, going over to my source control system, of course, and then committing using a commit name that matches the video name. And do remember also that you can get to all of this code over on github.com/Ben Tristram. You can navigate through to the Unreal course, the Battle Tank section, or you could directly go to github.com/Unreal course, and then you can choose stick on the master branch. And if you look at the 14 commits, you'll see that each one of these corresponds to a video. For each of those, you could choose to go to that commit, and you would be able to download the files if you want to. You can browse them, download them, clone them, whatever you like. So you can get to the end state of every single video in the course, which is pretty handy. Cool, so I'm going to go ahead and commit this now, and I'll see you in the next video.